Hi everybody. I wanted to just talk to you guys a little bit about Facebook math. Okay. Now Facebook, great program, great thing out there for connecting people and whatnot. All these friends of ours. So here's you in the center, connected to all these people that you know, and then they are connected to other people and so on. Okay. Well, we call this in mathematics something that looks like this. We call that a graph. Okay. Where each person, okay, that's connected in this network here, each person is a vertex, okay, and each connection here, each quote-unquote friendship, would be an edge to the graph connecting these people here. So me, as somebody who's on Facebook, all of my friends become what we call a neighborhood to me. Now, if I include myself in that group, then it's called a closed neighborhood. If I'm not included in that group, then all those friends, all of my friends, would be considered an open neighborhood, my open neighborhood. Okay, and that all consists of people next to me. So my friends really are what we might call in Facebook, in the larger kind of enigma that is Facebook. My group of friends would be adjacent vertices to me. Okay, all of those vertices that are directly adjacent to me are my friends. Now, some interesting things that kind of pop out about that. Okay, and we can demonstrate some interesting relationships mathematically. For example, in any group of 6 people, okay, in any group of 6 people that might exist, when we connect those all together here, let's say that we draw connections to all of them here, okay. In any group of 6 people, what we can demonstrate here is that there will either be a group of 3 in there that all know each other, or a group of 3 that are complete mutual strangers to each other. Kind of one or the other, but that is going to exist in any group of 6. Okay, now to demonstrate that, it's actually not all that hard to do here, seeing as it is close to Christmas here. Let's use red and green. So let's say, for example, that red refers to strangers and green will be friends. Okay? So put a little slash there. So let's say here's an individual here, and out of a group of 6 people here, okay, here we're going to identify this. One person here will definitely be connected to 5. 1, 2, 3, 4, 5. Okay? Now, let's just say, for example, that this is like a social network here, that this person is friends with all of those people right there. Now, when I start to compare the relationships between these people, if these 2 people know each other, then we immediately have a group of 3 that are mutual friends. In fact, if any of these 2 people know each other, then there is going to complete a group of 3. So let's try to avoid that. Let's see if we can get around doing that. So if we connect these people here, those people there we go. Aha! See, we've managed to avoid creating a triangle here. But now, what's the relationship between these 2 right here, for instance? If they know each other, well, then there's a triangle of 3 mutual friends. If they don't know each other, then there, right here, between these 3, is a triangle of mutual strangers. No matter how you draw it out at this point, a situation like this is unavoidable. So in any group of people, where there's 6 people here, there's going to be either a group of 3 that know each other or a group of 3 that don't know each other. So when you look at it like this, when you're sitting here on Facebook looking at all your friends here, essentially, either a couple of your friends have to know each other, or there's a group out there that don't know each other at all. Now, this gets even a little bit more interesting. Let's take this a little bit further here. Let's say that we've got a group of 10 people. Okay? What sort of relationships have to exist in there? Well, we can show here that if you've got 10 people, that you're going to run into a situation here where there's either, for example, a group of 3 that are either related as friends or mutual strangers, or there's going to be a group of 4 that are all connected as either friends or mutual strangers. Now, to take a look at the way this one works out here, if you've got let's just say, for example, we're going to talk about strangers here. So if this is us right here, you are connected to, in a group of 10 here, if you're part of a group of 10, there will be 9 other people in that group. Now, if we're going to split this thing up here, and out of that group of 9, you're going to have at least 5, or actually I should say this way, probably at least 4 connections that are either friends or strangers. Okay, in that group of 10. What I mean by that is, let's say you've got 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, at least 4 of them are going to be friends or strangers to you. Okay, because that's kind of like you're halfway. Once you go beyond that, you're going to get 5, 6, 7, 8. If I go less than that, if I've only got 3 friends, then there's got to be 6 that I don't know. So it's going to bounce back and forth there a little bit. But let's take a quick look at this. This kind of breaks it up into 2 interesting situations for us here. Let's just say, for example, that here's you. And let's just take a look at that group of 4 that we bump into. Let's say that these are all friends to you. Okay. So now remember, there's still like what is this? We've got here. We've got 5 here. There's still 5 other people that we're not addressing in this little situation here. But right here in this little group of just 4 people, okay, and these are all friends here. Right here, there could, if I try to avoid the connection here, again by connecting those guys right here, if I try to avoid having a third friendship connection here, then I'm stuck connecting those 3 as strangers, in which case there's a group of 3 that are strangers to each other. Okay? If I try to avoid connecting them as strangers, okay, then I'm stuck connecting a group of them as 2 of them as friends. And so either way, there's going to be this group of 3 friends here, or there's going to be a group of 3 strangers. But we can argue this a little bit more complicated here. And actually, if we suggest here, sorry, I want to show you how this group of 4 pops out. Okay, so let's say that here's our group of friends here. Now let's try not to connect anybody else here as friends. Let's say that the rest of these guys are strangers. That means those guys are strangers, those guys are strangers, those guys are strangers. And then now we start to connect the groups here, and then it turns out, well, we've got a whole bunch of strangers there, and those guys right there all end up, if we choose not to connect any of them with friends, if we don't want to have like another connection there that creates a group of 3 here, then we've got to have a group of 4 that don't know each other. Okay? And so we can argue that out of a group of 4 people, a group of 5 people really in that set of 10. Now, the other situation here that we could run into is you. And this is kind of a nice argument here too. We can also argue this with you connected to 6 other people. And let's say we're connecting these as all your friends out of that group of 10 people. Okay, so we're going to take that group of 6. Now this could be more. Okay, obviously there could be more people here because there are at least 3 more people included here. But the way this argument works is this: here's you connected to these 6 people. Let's say you're friends with all of these people here. Now this could be more or less. If we lose, let's say we lose a person here. Okay, so we're down to 5. If we lose this person right here, because let's say that's a stranger to you, then what we end up with is that group of you plus those 4 people that were strangers, and then you can argue the same thing with that group here. But here we've got these 6 people, and we're going to say that you're friends with these people. If I choose to connect anybody here as friends, we've got a group of 3 that are friends. Okay? And that's easy enough here. Now let's say we've got, well, let me say it like this. You've got a group of 6 people here. Well, we just showed a few moments ago that any group of 6 people is going to have a group of 3 that are either mutual friends or mutual strangers. So that means that if what I've got here is out of these 6 here that I'm connected to, 3 of them are either going to be connected like that, in which case there's 4 of us that are all connected to each other. Okay, and there's that group of 4. Or I'm going to end up with 3, okay, or sorry, 4 here, let's say, that aren't connected to each other. Sorry, I should say it like this. Either there's going to be 3 that are that know each other there, and because they know me, there's this group of 4 that are all connected, or there's going to be 3 out here that aren't connected to each other at all, and those are my 3 mutual strangers here. So no matter how you cut it, in a group of 10, you're either going to have a group of 3 mutual strangers or friends, or you're going to have a group of 4 mutual friends or completely mutual strangers. And again, it just works up bigger from that. You can show all sorts of connections. In fact, if you want to demonstrate that there's a group of 6 necessarily that exist in a group, you can do that. You just got to get this in larger and larger group. What's interesting about this kind of a question here is that if you're looking, for example, to demonstrate that a group of people here has 5 mutual friends or 5 mutual strangers altogether, the answer to that question of how many people that necessarily requires for that to be true, we don't know what the answer is to that yet. So that's one of those unsolved problems. So, and it doesn't seem like that should be very much further beyond like a connection of 3 or a connection of 4. But yeah, you just go, 1 more person out or 2 more people out in terms of the number of friends and strangers, and we don't know the answer. Kind of neat.